Okay, welcome back to our next video on solving quadratic equations. You thought that you had escaped the radicals, didn't you? Not quite. So in this case, we're actually going to look at solving a radical equation. Now, you guys saw this in the last unit a little bit, but we're going to add a little extra spice to this situation, okay? So in any case, when I look at this situation, remember when you're solving for any radical, the goal is to isolate that radical first, okay? Isolate the radical, get this guy on its own, and then you can get rid of the, the root sign by squaring both sides. So that's what we're gonna do. We're going to isolate this radical. That means that I need to bring whatever is here, I need to throw it over there, okay? So I'm going to subtract 4 from both sides so that my radical is isolated and on its own. So it's going to look like this. So it's going to be the square root of 6 minus x equals now x minus 4. And what you're going to do is to get rid of this square root situation, we are going to square both sides. And in doing so, this will cancel out my square root. So I'll be left with 6 minus x. And on the right-hand side, as you know, this is going to be x minus 4 all squared is going to turn into a perfect square trinomial. So I don't know if you recall this situation where you have a plus b all squared. This equals a squared plus ab plus b squared. So you're going to end up with a squared plus 2ab plus b squared. If this is a negative sign, then that means that these would also be negative signs. And so this would be a minus. And so we can generalize that. So this is the representation of a perfect square trinomial. And if I multiply x minus 4 to itself, I'm going to get x squared minus 4 times x. And then I'm going to double it, that 2 times, right? So I'm going to get 2 times 4 times x. And I'm going to get plus 4 squared, which is 16. Okay, so let me get rid of that. That was just a sidebar, just to remind you of that situation. So I have 6 minus x equals x squared minus 8x plus 16. Okay, and now when you get to this step, our intention again is to make this entire thing equal 0. So I want to combine like terms and I want to pull everything together, okay? So if you notice, I have a minus x here and I've got negative 8x here. I've also got a 6 and a 16. Those are like terms. I can combine them together. So what I'm going to do is I'm going to move them from the left-hand side to the right-hand side. So I'm going to add x here. And I'm going to subtract 6 there. So now on the left-hand side, I've got 0 because I just removed those terms. And on the right-hand side, I have x squared minus 7x plus 10. And now we have an equation that looks very similar to, again, we're always looking to simplify what we're doing, and we go back to, again, that first video, that intro video that we looked at. So this is something we can solve. I'm looking for 2 numbers that multiply together to give me positive 10 and add together to give me negative 7. I think that's pretty easy. We know what those numbers are. 2 and 5 would make sense for this one. So that's going to give me 2 and 5. Both of them have to be negative in order for this to work. So that means that I'm going to have 0 equals x minus 2 times x minus 5. So remember that if one of these equals 0, the whole thing will equal 0, okay? So I'm just looking for places where x minus 2 equals 0 and x minus 5 equals 0. And that's going to happen here. X equals 2 and x equals 5. Okay, so again, let's quickly go back and recap what we just did so we're all clear on what's going on. When you're solving a radical equation, our first goal is to isolate that radical, okay? Isolate the radical. Once you isolate the radical, then we are squaring both sides, right? We're taking the square of both sides of the equation. And in this case, we just ended up with a perfect square trinomial on this side. Okay, so you can expand and simplify. You can use the distributive property. If you understand this idea, you know, the a plus b all squared equals a squared plus 2ab plus b squared. Use that. If you don't, it's okay. Just expand like you normally would, like x minus 4 times x minus 4. It's not a problem. Okay, go about it that way. And once you're at this step, what you're doing is you are combining like terms. You're simplifying, right? You're going to combine like terms. Okay, and in your last step there, once you combine like terms and you set the whole equation equal to 0, then we can start to see this trinomial that we can factor, right? So we find those numbers that are going to help us factor from here to here. And now we know that if one of these binomial factors equals 0, then the whole equation will equal 0. And once I'm at this step now, I always want to verify, by the way, okay? Especially when I have a radical, because with radicals, remember our restrictions, right? We have a restriction here. My restriction on this radical would be that the radicand, that 6 minus x, has to be greater than or equal to 0. So that means that there are certain values of x that actually won't work. And I have to make sure that my solution is not one of those values that isn't going to work. So that's what I'm going to do is I'm going to plug both of these numbers in and make sure that either both of them work, one of them works, or neither of them do, right? So we're going to take a look at that. So I go back to my original equation. I don't want to ever use the changed form. I always want to go back to what I started with, which is right here, square root of 6 minus x plus 4 equals x. So square root of 6 minus x, plus 4 equals x. And I'm going to substitute, let's do x equals 2 first. Okay, so I'm going to substitute x equals 2 and see what happens. So here's 2 and here's 2. And then I'm taking the square root of 6 minus plus 4. Okay, let's see what happens. 6 take away 2 is 4. So I have square root of 4 plus 4. Here I have 2 plus 4. That will equal 2. And then I have 6 equals 2. Okay, what just happened? What's the problem? We've gone and verified, and we have found that the left-hand side does not equal the right-hand side. So that's what's happened here is you plugged in, so we didn't make any mistakes. This is how it's supposed to look. We've gone and thrown in our number 2 and found that actually left-hand side does not equal right-hand side. Okay, so that's going to be a bit of a problem. That tells me that x equals 2 isn't a valid solution for this example, okay? I'm just going to jump to a new whiteboard because I, again, it's stalling on me for some reason. Okay, so let's go back to this. So we just saw that your left-hand side and your right-hand side does not equal. Therefore, that's what this little symbol means. That means therefore. Therefore, x cannot equal 2. This is not a solution. It's acting like it's a solution, but it's not actually a solution. Okay, let's try 5. Let's say x equals 5. So when I go and plug in 5 here, plus 4 equals x. So when we go and plug these values in, I get 6 minus 5 plus 4. Does it equal 5? Let's find out. 6 minus 5 is 1. The square root of 1 is equal to 1 plus 4. Does it equal 5? It sure does. Okay, left-hand side does in fact equal right-hand side. So that tells me that x equals 5 is a valid solution. Okay. And because of what we saw earlier from this situation, x equals 2 is not a solution. And in fact, we also use the word root to describe this. So I would say that x equals 5 is a root of this equation, and x equals 2 is not a root of this equation. Okay? Now, this makes a lot of sense because if I go back to my radical, which was 6 minus x, and then I had plus 4 equals x. Remember our restrictions. The radicand cannot be negative. That means that 6 minus x has to be greater than or equal to 0. If 6 minus x has to be greater than or equal to 0, if I go 6 minus x equals 0, I can slide my x over, and that will give me 6 equals that. That means that x has to be less than or equal to 6. Okay, x has to be less than or equal to 6. X equals 5 fits that condition. X equals 2 fits that condition, except it doesn't make this equation true. So we run into some issues there. Okay, but again, just a little reminder on the restriction situation so you know what to anticipate.